Questions, once again, which we hadn't time to ask on the previous part of the recording? Okay, let me continue then. Receiving payments. It consists of three parts. First of all, the receiver wallet should get this consignment data. Second, it must validate that the consignment is correct, validate that indeed the payer owns those assets, they are being transferred to the new outputs, correct outputs, and the internal structure of the data is valid against the schema, execute the scripts. A lot of stuff is happening during the validation process. It's fortunately hidden behind the RGB SDK as a single call. And as a result of validation, you get just a detailed report about all the issues that are happening. I will be covering that. And the final part, when you are happy with the consignment, you need to accept it and make it part of your RGB stash. And that is the point where you will be able to start spending those assets. So the first part starts with you receiving the consignment. Today, you receive the consignment via other channels. So we discussed this, that it may be shared via servers, vendor-based, or Bifrost servers in the future. But today, you can send them as a binary data backstream to your receiver, and he needs to paste it or import via the user interface. The wallet UI will get those data and pass it to controller. In the future, there will be other ways, and in that ways will be initiated from the network side, where the consignment will arrive from the vendor server, or the wallet will proactively check Bifrost server for the new consignments awaiting for the payment. So these are three options of getting the consignment. Once the consignment is already at the wallet controller, we start the verification phase. We call the single verify function to the RGB SDK node. And this is the only point when RGB will be talking to external world. So if you embed the RGB node into your wallet, or if you have RGB node set up on your server, you need to know that at this point, RGB, your wallet, your software, your firewalls has to be configured in a way that it must allow RGB to talk to external network. Namely, it will talk to Electrum server. And as a part of the RGB configuration, we have this option of providing Electrum server. Today, we are running on Electrum server. In the future, we plan to deploy our own indexing server, which will be more efficient in terms of API. But today, we use an Electrum server API, so your wallet will need to provide users with a public Electrum server, or users may use their own Electrum server if they have one. And it does all the validation. As a result of this validation, it returns a validation report. And the case is that instead of failing on the first issue in the consignment, RGB node runs the full validation process till the end always. And it just collects all the issues that it has into a report. So report actually consists of a list of errors, a list of warnings, and a block of information, because there are different severity of different situations. For instance, each absence of the transaction in blockchain results in an error, and it may happen because some rework has happened or anything like that. So there may be multiple circumstances, and it will be responsibility of the wallet to define the policy which of these warnings may be ignored, and which of these errors has to be reported back to the user via the user interface. So the user may decide would he like to accept such kind of consignment or not. Probably we will need to make a part of the documentation the list of the possible errors and mistakes. The most of errors, of course, is a failure errors. Right now, I see only one situation where the wallet may ignore the error coming from the RGB node. It is related to the transaction we call it witness transaction. So whenever you do a payment and you publish that transaction from PSBT, which we was covering in the second phase, we call this witness transaction. And because it may take a while for the witness transaction to get mined, and the consignment may get to the user before the transaction actually is mined, in that case, the RGB node wouldn't see this transaction, and it will report a error. And wallet has to handle that situation and be smart enough to wait for the transaction to be mined. And it's up to the wallet to decide how he will put that into the user interface and notify the user about this progress. So this part happens here. Let's say that we has the transaction mined already, and we are happy to proceed further. And if there was no errors, we have already mined transaction and the consignment locally. And with that, Bitcoin wallet, RGB wallet controller need to do a set of quite important tasks, and we called it accepting consignment. The first task that is need to be performed is it need to ask RGB node to extract out points from the consignment. What are out points? The consignment contains a lot of state transitions, and only one of few of them are actually related to the payment, and they're called out points. So basically, these are where the funds are earned on the user account. And because in many cases, when you use UTXO to pay with RGB, this UTXO and endpoints will be blended. And you remember that blinding factor, blinding secret from the first part of the presentation. And here you will need to use it. But because you probably created a lot of invoices, you don't know which of the blinding factors you need to apply to which of the consignment you received. And there is no relation between them. So in order to establish that relation without asking user or without providing additional information through the Bifrost server that can leak confidentiality, what you do is you ask the RGB node to extract the information about these out points or endpoints from the consignment. And you use this information to find secrets in your local database where you store that blinding secret on the first phase. And once you have this blinding secret for the consignment, you call the accept method, providing the RGB node both the consignment and the secret information. With this information, RGB node adds all the data to the stash and reports success. Once you did that, again, you are in a situation when you own the asset, it's in the RGB node, but you don't know how much of the asset you have received and on which outputs it's ended up. So what you need to do is to sync up the list of the outputs with RGB assets with RGB node. And you use the sync call for that. And what you get in return is actually not just an unspent outputs, but all historical outputs as well. And you will filter them inside your wallet, and if you, depending on the situation which you need to report, if you need to report a history, you will report all of them, or if you need to report the current balance, you need to check which of them are unspent and which of them are related to unmined transactions. And important question in this regard is the fact that we can have a reorgs in the blockchain. So what happens if a reorg happens and some of the transactions that were mined are not mined anymore, or they are mined in the different blocks, or today they are not mined and tomorrow they will be mined once again? How to deal with all this situation? The way it deals with them is very simple. RGB node works in the always write, never delete mode. So whatever consignment it gets, it stores it forever. For now, forever. In the future, we will probably have some prune procedures, but today you can't delete any information from RGB stash. And it keeps all the information about all the assets ever owned. And with that information, it doesn't care are they part of the mine transaction or are they part of the transactions related to Lightning channel are they part of the transaction that were part of blockchain but later removed due to rework? It doesn't know anything about that. And as you've seen, it talks to Electrum server only during the validation process, but never during synchronization. So it is job of your wallet to see through the list of assets and outputs and sort that output according to your wallet policy. Which of them are mined or not? Which of them are part of the Lightning channel or not? And basing on that, you prepare the information about the balances and history for the user interface. And this design allows a very simple handling of all potential reorganizations, blockchain reorganization. It can be easily combined with the Lightning channel or any other complex situations, because basically RGB node does its job, keeping the stash and making sure that everything is wallet. It's a validating node, and it's only job it does. And your wallet does its job, presents the information about transactions for the user interface. So that's all for the wallet integration procedure. And I think we can finish the part of the presentation, this part of the presentation for now. And if you have any questions, we may discuss them.
Okay, so the presentation is over right now, right, Maxim?
Correct.
Okay.
Yeah, well, I can bring slides back if you have any questions, and we will need to get back to the slides.
Hi, excuse me. Is there any information regarding how in the wallet the asset is viewed? Because I hear a lot of, in the future with the NFTs and tokens, is there going to be like a viewer of these assets? If it's like an image or if it's a sound, can you hear this asset? Is that there's somewhere going to be integrated into the SDK or any of that code?
If we talk about NFT, and the same applies for fungible assets, all this information is a part of the asset data. So whenever you query RGB node about the owned assets with this sync comment or list asset comment, you get a, let's say, JSON, just for simplicity. You get a binary data, but they are processed by SDK. And if you use the RGB from the JavaScript or from mobile application, you will end up with a JSON. And this JSON structure will have all information about each asset. So for fungible asset, it will contain information about ticker, name, total supply, and the rest, whatever it is. For the NFT, it will contain whatever NFT-related information was imported into the RGB node. So for instance, if there were image data as a part of the NFT genesis, they are got into RGB node and they will be returned back as a part of this JSON. And of course, it will be up to the wallet software to present this information as an image to the user.
Got it. Thank you very much.
Yeah, you're welcome. Any other questions? Okay, I think we can wrap that up. Olga, are you around?
Maybe another real quick question. How will the wallet connect to the RGB Lightning node? Would it be like through the QR code? You know, you kind of scan it and it'll connect. Would it be that type of functionality?
Well, the wallet itself, it's up to the wallet developer to choose the way it will interact with RGB node and Lightning node. So let me split the answer into few pieces. The first piece is that how RGB works with the Lightning. So RGB node has nothing to do neither with Bitcoin blockchain nor with Lightning network and Lightning payments. So it doesn't know anything about Bitcoin payments and Lightning payments. It's not the task of RGB node. I have shown during the presentation that it talks to Electrum server only once, and the rest is done by the wallet itself. To work, the RGB payments to work with the Bitcoin network and Lightning network, we need two other components. For Bitcoin, we need a wallet and the Electrum server. And it connects to Electrum server based on the configuration that is provided by the wallet. How the wallet gets that information from the user via user interface, via QR code. It sticks to the default vendor Electrum coming with a wallet developer. We don't know. It's a part of the wallet developers to decide. Regarding the Lightning network, there is a special LNP node for the Lightning payments, including RGB Lightning payments. And that's another node with a separate API, which we will devote a separate presentation. And they work well together, so they can talk to each other. And the wallet developer has three options how he will use the RGB and LNP. It either may be embedded into mobile wallet, so the mobile wallet will run the full RGB and LNP node, and then you connect it by the fact that you have it inside. The second, you can run it on somewhere on the server, and RGB and LNP node can be either run on your personal server or by a wallet developer. In that case, you will have a custodial wallet. And again, in both these cases, it's up to the wallet software to decide how to talk to the RGB node. So if it's a vendor-based RGB node, then it will be hard-coded into the wallet. If it will be a personal user server, the wallet must provide user with the ability to insert the connection string, again, via QR code or just typing in. Like today, wallet provide the user ability to insert the information about Electrum server. And there is a third option, which is more complex, and it's only applies for LNP node, where you can split the node into parts, and one will be server side and the other wallet side. And wallet side, you will have a signing part, and the server side will be non-custodial. But for now, we have not completed this design, and we will see is there any demand for this option at all, because it's quite a complicated setup and not sure which benefits you get. You can get all the benefits you need from this design via other options. Like you can have two LNP nodes, two Lightning nodes, one in the wallet and one on the wallet side or with a personal server. And with the invoice format I was described, you're just creating invoice specifying that pay to my mobile, or if I'm offline, pay to the my personal server at home, or if it's offline, pay to the wallet Lightning node. And then wallet Lightning node will pay to my wallet when I will be back online. And you can make that part of the invoice, and you don't need to split the node. So you already mitigated the problem of your mobile Lightning wallet being offline.
Thanks again.
You're welcome. Okay, seems we don't have other questions. Olga, are you around?
No, I'm here. I'm just waiting.
Okay.
I'm just waiting for the guys to probably ask any questions if they haven't. If not, we can for sure wrap this up. 3, 2, 1. Okay, then I think we can wrap this up. Thank you everyone for joining our call today. Maxim, thank you for the presentations and answering the questions. As usual, all the materials would be uploaded to our repos, FAQ website, and YouTube channel. If you have any questions, you know where to find us. Have a great day. Thank you for joining us. Bye.
Thanks. Bye.
Thanks. Bye.
Thank you.